A single second can be counted pretty easily. Usually, I think of it as 1 Mississippi, 2 Mississippi. Not rushing it, but not slowing it down too much either. Just a normal pace. If I want to get really fancy, I can grab my watch, and I will be able to count seconds even more accurately that way. For our purposes, our watches are pretty accurate, and it's not going to matter whether we're off by 1/10 of a second. If we want to get super fancy, we can use our smartphones, and those will count to the 100th of a second. But where did the definition of a single second come from? There has to be a standard somewhere, and there is. That's what we're getting into in today's video. Let's get started. A second is traditionally and historically defined as 1/86,400th of a day. That was defined by dividing the Earth's rotational period into 24 different segments, dividing each segment into 60 parts, and each of those 60 segments into 60 other segments. Each of those segments is a single second, and there are 86,400 of them in a single day. However, the modern definition is a lot different. It's based off of the radiation that a cesium atom gives off. The cesium-133 atom gives off radiation, and so we count the number of times that it radiates with more energy and less energy. A second is now defined as 9,192,631,770 vibrations between the high and low frequencies of radiation. However, since we have the clock so accurate, we do have to add a leap second every now and then because the Earth's rotation is not always the same. Atomic clocks around the world basically hold a vote to what the time is so that we can have the most accurate time possible. Then people decide when to add leap seconds so that the time is more accurate. The time for all of these atomic clocks is called International Atomic Time. Civil time is what is the most accurate with regard to the rotation of the Earth. This form of time is also known as Coordinated Universal Time, or UTC. A third variation of time is UT1. It's not exactly the same as UTC because it uses the position and rotation of the Earth with regard to the Sun rather than the vibration of a cesium atom. However, seconds are added and subtracted from UTC so that the difference between the two times is always less than 1 second. In ancient times, the second was defined as 1 day divided by 60 times 60. You have 1 day, you divide it into 60 parts, and then you divide those 60 parts into 60 parts. The best timekeeping devices of this time period were sundials and water clocks. With sundials, time was measured in degrees of an arc. Starting in the 14th century, the first mechanical clocks began to appear. However, these clocks did not divide an hour into 60 equal minutes. Sometimes the clock faces were marked with halves or thirds or quarters, maybe even twelfths, but it was not common to mark a clock with 60 different units in an hour until later. These mechanical clocks kept mean time, which didn't differ between summer and winter. In the last half of the 16th century, the first clocks with seconds came to be. The first clock to have seconds clearly marked on it was made between 1570 and 1590. Nobody knows who it was made by. In 1656, the first clock to accurately measure seconds was made. By about 1730, there were clocks that could keep the accuracy within a second in 100 days. In about the 1940s, the first quartz oscillator clocks were made. After some time, it was pretty clear that these clocks kept better time than the Earth itself. In 1950, people proposed to define the second as a fraction of the year rather than the fraction of a day. This is because the Earth's rotation is not super stable within its daily orbit, but its rotation around the Sun is very stable. In 1952, the second was defined as part of a year, a fraction of a year. However, as we all know now, atomic clocks prevailed. Since their accuracy is within 1 second in about 100 million years, atomic clocks are about the standard for today's time. So in answer to the question that we've already stated, how long is 1 second? It's the time that it takes for a cesium-133 atom at 0 Kelvin to vibrate 9,000,000,000 192,631,770 times. That's all I've got for today's video, but if you enjoy the content that I make and want to continue fostering this relationship that I have to you, between me and you, then go ahead and hit the subscribe or the share buttons and then comment what you did below and I will reply back to you. If you've already done those things on other videos, that's fine. Comment if you learned something below as well. And I'm going to ask you one more thing before I sign off. If you want to, hit the like button. Thanks for watching.